So following on from the previous video, we've established that as x tends towards infinity, positive infinity, f of x tends towards infinity. Okay, so now we need to consider when the derivative will be zero. Well, looking at our function, when will the gradient be zero? So in order to find out, in order to answer that question, we need to differentiate this. So now let's find the first derivative. Okay, so start out with our original function, differentiate it. So what you've got here is like a well, one thing multiply another, use the product rule. So differentiate this, leave this the same, and then leave this the same, differentiate this. That will then give you this, and then blah blah blah. It will then give you this, and then blah blah blah. It will then give you this. Okay, so the first derivative is given by this. Now, because we want to know when the gradient will be zero, we need to set this thing to be zero here. So because we want to know when the gradient will be zero, so set this thing here to be zero. Okay, so basically we want to solve this now. When is it that, when will x, what will x be that will make the whole thing here be zero? Meaning, when will the, where along the x-axis will the gradient be zero? So it's a matter of us solving this. Now remember that trick, that quadratic trick. So remember, let u be this thing here. So let u be the natural log of x. So let this be the bubble here. So imagine this as being the bubble. Imagine this as being a bubble here. So so you've got u squared, because this thing squared. So that's u squared. So it's really us translating this into a quadratic here, and then solve the quadratic, and then translate the u back into the x. It's just a trick that we developed in one of the early videos. So now so let u equals this thing here. So so this thing here becomes this, and this becomes this. So so look at this. Looking at this, you've got this plus this. U is in common here. U is in common here. Factorize it. It will then give you this. So when will u be zero? You see, when you put 0 into here, blah blah blah, u will be zero. Sorry, it will be zero when u equals 0 and when u equals -2. So now translate it back to the x. So so when u equals 0 here, remember earlier we said that u equals the natural log of x. Remember from earlier, from here. Okay, so u equals the natural log of x. So turn it back here. So u equals this. So basically this would imply that x equals 1. So you see, when x equals 1, the gradient will be 0. Okay, and then -2 equals this. Exponentiate both sides. That will mean that x equals this. You see, when x equals this here, the gradient will be 0. Okay, this, by the way, approximates to this. Okay, so when x equals 0, the gradient will be sorry, when x equals 1, the gradient will be 0. When x equals this number here, the gradient will be 0. So our graph will look something like this. So we know that well, along when x equals 1, somewhere along here the gradient will be 0. When x equals e to the power of -2, the gradient will be 0. So we now want to know the value here, or the values of the two. So let's put this into here, and then this into here, and then that will then give us so basically putting the 1 into our original function, it would be 0. Okay, so that means that looking at our graph here, that will mean that we've got a critical point here. So we know the gradient here will be 0. So now let's put this into here, and then into here. Okay, that will then give us this. Hang on. So we are now putting so originally our function was this, our original function. Now we are putting e to the power -2 into there. So blah blah, it equals this, and this approximates to this. So what that means is that the gradient, the coordinates here, the gradient will be 0 dead on here, and dead on here. Okay, so we can now guess the gradient would be 0 here, and then it would be 0 here. Okay, so we can now guess this. It won't do I don't know, it won't do, well, we can now guess that it's going to do something like this, because we know the gradient would be 0 here, and we know the gradient will be 0 here. Okay, so that's our guess. In the next video we're going to double check everything. Okay.